Okay, so hello everyone. We would like our group would like to present about how to achieve a sustainable hydrogen society in the Hokkaido region. So here's the content. So we would like to start with our definitions about what is hydrogen society, and then to give some background information about hydrogen, and then finally to explain some of our solutions to achieve hydrogen society. So what is hydrogen society? So what we think is hydrogen society is like first, hydrogen is used in place of fossil fuels whenever possible, wherever possible, and system for producing, supplying, storing hydrogen itself are in place, and in the additions, other sustainable energy sources are also utilized together. With the ultimate aim is to achieve net zero emissions and sustainable society. So this present will mainly focus on hydrogen because it is also it's still like one of the challenging aspect of hydrogen society. So first, I would like to start with the background information about hydrogens. So the demand for hydrogen in 2023 was over 97 megatons. However, most of the hydrogens is used in traditional applications such as in steel manufacturing as a syngas to reduce iron oxide, in chemical synthesis for ammonia and methanol, and in petroleum refining. On the other hand, new applications of hydrogens like are currently in the research, like say first is heating using pure hydrogen or syngas, in transportations for the fuel cell electric vehicles, or in power generations. However, those new applications currently only occupy for less than 1% of hydrogen use. The reasons the main reason is because are the cheap, mainly especially cheap and or efficient alternative exists. So in order to achieve hydrogen society, we need to greatly expand the new applications of hydrogen. So the main issues now we need to solve is to lower the cost. And in addition, we need to prioritize low emission hydrogens because as you can see in the, it's a bit small, but in the image, so most of our current hydrogen is produced for fossil fuels, and the process itself can already produce a lot of CO2. So if we want to achieve a good like net zero emissions, so we need to prioritize more on low emission hydrogen productions. So for the productions, next Tatsumi-san will explain about the production system of hydrogen.
So next, I will explain about hydrogen production and current situation or some issues. So this slide shows an overview of hydrogen production process. Hydrogen processes are categorized into two processes, from fossil fuels and renewable sources. So to extract hydrogen from renewable sources, the principle are water splitting, such as electrolysis, or biomass process, such as fermentation or biomass pyrolysis. So this slide shows some representative way or feasible way to hydrogen production with high efficiency. So among these three processes, electrolysis is the most feasible way to large-scale hydrogen production or combining with renewable sources because of its high quality of produced hydrogen or some technical aspects. This slide explains the details of electrolysis. The figure on the left side is the configuration of a typical way to hydrogen production by electrolysis. This is called PMEC. And the table on the right side is a comparison for each principles for electrolysis. There are PMEC and AWE and SOEC. I cannot explain the details for each principles, but as a conclusion, it can be said it is important to select the best way to electrolysis depending on size of project or regional characteristics or some characteristics of energy sources. And when it comes to combining with renewable sources to electrolysis, so PMEC is the best feasible way because of its dynamic properties. So next, I will explain about some issues, current issues. So one of the barriers for hydrogen production is the cost. For reducing cost, the expansion of scale is necessary. From this viewpoint, the Tohoku region can be best location for hydrogen production because of its vast land and plenty of resources. So the figures there is the example of large-scale hydrogen production factory. This is alkaline type of electrolysis research field in Fukushima Prefecture. In this research site, 20 megawatt of solar power is produced and 10 megawatt is used for electrolysis.
Okay, so yeah, we have explained the issues with the use and the production. So in addition, hydrogens also have other issues, including first is the safety issues and the incompatibility with the current infrastructures, which basically mean we can just not replace, say, natural gas with hydrogen gas easily. And because of this, there's another issue is that the lack of new infrastructure specialized for hydrogen. And also there's a hesitance against change. So in our conclusions, we need policy from both government in form of regulation and support, as well as research. So next we will explain about what what are our suggested solutions to achieve hydrogen society.
Right. So when we're using hydrogen, of course, we have to store hydrogen. And there are two types of storage methods. One is chemical and one is physical. Here is the figure that shows how chemical storage works. The hydrogen obtained will be stored in the form of some other chemicals, and then whenever needed, it will be extracted from it. But this is not very favorable because that's basically the same thing as the hydrogen production. So the physical storage is maybe more favorable in this green hydrogen society. So there are two main methods. One is the gas storage, which we have seen in the Fukushima Denso, and one is the liquid hydrogen storage. They come in both pros and cons. For the gas storage, it will have to withstand a very large amount of pressure that's gonna build up inside of it because it's compressed, and it is also very energy density is very low. On the other hand, liquid storage doesn't have to care about the buildup of the pressure within the tank. However, there is a main issue that whenever there's a heat leakage, the liquid hydrogen will become gas and it will build up pressure and disaster might happen. So here is some comparison between the chemical storage and physical storage. And now I've talked about the storage, and now I talk about what could happen in this kind of storage tank. So inside the storage tank, hydrogen is of course there and might be absorbed to the surface and make it brittle and crack propagates and disaster happen. So we don't want that. So our solution is to mitigate this HE, the hydrogen embrittlement. So there are studies ongoing to reduce the amount of effect of this HE. One of them is shot pinning, and one way that I would like to suggest is a barrier coating using thermal spray. So I don't have much time, so I will jump to the energy resources that can be obtained in Tohoku region. So hydrogen society, we've seen that hydrolysis is one of the main way to produce hydrogen. So we need electricity, but we don't want it to be very polluting, and we want to want it to be carbon neutral. So we have to use this eco-friendly energy resources. And one of them is, of course, solar energy. It's very hard to see, but if you take a look at this orange bar, in Sendai, it is quite uniform throughout the year. But if we take a look into Akita Prefecture, it is quite easy to see that during winter, the amount of sunlight is very limited. And from this figure, we can see that we really have to consider using solar like throughout Tohoku, whole Tohoku region, but we want to use it in certain regions only. And also here is some explanation about the wind energy. Basically, Tohoku region is surrounded by long coastline, and coastline causes strong winds. And as you can see from this figure, the wind speed is quite high according to this map. And there are actual companies actually making wind farm. This is just one example. There are others. If you search internet, it will pop up very frequently. And now here is geothermal part. As you can see from the figure in the right-hand side, where it shows the geothermally active places and regions and or areas, whatever you call. So there are really a lot of them, but we cannot use all of them because some of these places are used as onsen and some tourist attraction places, and local people wouldn't like to have this big power plant in front of their yard. So this is an issue, and we have to make a solution. So what we need is consensus between government, company, and local people. So what I'm suggesting is that this is, although very abstract, I think it would be pretty good if a company can build a geothermal power plant by the support of the government, and then the company provide some amount of electricity to the local people, and the local people will, of course, will work and give tax to government. So ideally, it would look like this. Okay, that's it from my part.
In this slide, this is the result of public opinion survey. This indicates current image of hydrogen. First question, what do you know about hydrogen energy? And second question is, speaking of hydrogen, from these results, people don't think hydrogen as energy source. This table indicates another result of public opinion survey. This table indicates hydrogen energy is how accepted by citizens. Compared with other technologies, for example, automatic drive and gene therapy, and so on. According to this table, hydrogen energy is information overload and complex system, and it is not accepted positively. So the convenience and usefulness to society is needs to be more simply indicated. This slide explains features in Tohoku region. Population of Tohoku region is declining and aging. So job creation is required. And Tohoku region has high potential for renewable energy sources, as we said. So local production for local consumption of electricity should be promoted. Some studies said that trust in the business entity is important factor of social acceptance, and a large-scale investment is essential. And before results, so institution should provide financial assistance to companies and to impose an obligation on the business entities to provide clear and simple information to public. In this slide, I'll show first solution. This solution, company do crowdfunding and company try to develop skills for realization of hydrogen society. Students invest and they want to set hydrogen production system at home. And government gave financial assistance to companies and students. And government imposed a tax on company using fossil fuels. This slide shows what is the merit of this solution. Increase students' familiarity with hydrogen energy, and this merit. This solution will be an opportunity to spread hydrogen usage.
I'm sorry, here has some problems. Okay, so next I want to explain another solutions. So as Chiba-san explained, one of the big problems with hydrogens now is like the people are not very familiar with hydrogen energy. So perhaps it's easier to approach and familiarize people with hydrogens by replacing a current resource. So, and as we know, natural gas is well, it's still used not together with electricity, but in a lot of places, natural gas like city gas and LP gas is still used in gas stove and in room heating and in for water heating. So perhaps it's possible to replace those natural gas with hydrogen. So the strategy is to first, so how we can achieve that? So we can install a small hydrogen production systems. So this needs a very small local one near each buildings or near the house. And such a system can produce hydrogens whenever we needed to use the gas. So we don't really need large storage capacity, and it can be run. It can use electricity from the grid, or or preferably it should use electricity from renewable sources, say like solar panels or wind turbines. And this electricity can be generated within a day and stored in the batteries and be used at night for the hydrogen production system. And so where can this solution be applied? So currently, natural gas is used in restaurants, residential house, apartments, government buildings. So these are the places that these solutions can be applied. And as alternatives, ammonia and methanes can also be used. And these two, ammonia and methanes, are easier for storage. So I think it might be easier if we for ammonia and methane to integrate into the current system of natural gas. However, if we want to focus on hydrogen, so the issues for now is still cost and storage and safety, especially when we consider about residential use like that. But however, in my opinions, without wider adoptions, there will be less incentive to solve the issues, and as well as there will be fewer study cases. So the strategy is to first, for some initial demonstrations at public facilities like say government buildings, universities, or like supermarkets, so on. And because it's the initial demonstrations, the cost has to be subsidized by the government. And the next step is to there has to be there has to be research into the issues encountered during such like an experiment showcasing like that, and in collaborations with universities, and in my opinion, more importantly, companies. And this can be a cycle, and until the cost going down, then we can start to increase the adoptions in residential and service areas, and then finally industry. So in our conclusions, there has to be an initial momentum from the government to start the adoption of hydrogen. So this is the end of our presentations. Thank you for listening.